Good morning. This is your Stats Sensei, Mr. Spensei, and this is another assignment on chi-squared for the test review. Preferred pets. A college student organization is conducting a study to determine whether students at their university have an equal preference for different types of pets. The university is considering pet-friendly housing and needs to know what kind of pets students are most likely to own to help shape housing policies. A random sample of 500 students. Okay, so we have an N as 500 from a population of at least 6,000 students. So we have a population of 6,000 who surveyed, and each student is asked what type of pet they own. If preferences were evenly distributed, each category would have 100 students. Actually, I think it would have 100 pets. The actual responses are shown below. All right. Use alpha equal 0.05 to determine whether college students equally prefer the same type of pet. All right, so to do this, and we did this in a warm up, but I still want to go back and do it because I just want to make sure that we are ready for our test. So I went ahead and I went into stat edit and I input the dogs at 120, the cats at 140, 80 for fish, 90 for reptiles, and 70s for who don't. Then I go, okay, they didn't tell me the percentages. Since they didn't, I know it has to sum up to one all the way across. Well, we have one, two, three, four, five categories. So I'm just going to divide this blue 2, divide by 5. And that tells me, oh, that's 20%, but that's not my expected value. To get my expected value, I need to go all the way up top and go blue 2, so L2 times expected value NP, so times my sample size, which is 500. When I do that, I get the 100. Oh, we want 100 pets, not 100 people. All right. So each one we expect to have 100. We expect to have 100 people who have dogs, and we expect to have 100 who don't have any pets at all. All right. So there they are. And basically, that these were all 20%, 0.20, 0.20, 0.20, 0.20, because we had one whole divided by 5, and that gave us our 0.20. All right. At this point, we might as well run the test, and we go stat test. And this is a goodness of fit test because we only have one variable. And observed is an L1, the expected is in our L2, and our degrees of freedom are categories -1, so 5 minus 1, which is 4. And we end up getting a chi-squared value of 34 and a p-value of 7.45 e to the -7. Be careful and pay attention to that e. So at this point, we have observed minus expected squared. That's our formula. And we just calculated our p-value. That means there's 6 zeros in front. 1, 2, 3, 4, 5, 6. Then we have that 7.451. Now you could have just said, hey, you know what? That's approximately 0. And that would have been all fine to say that that p-value is approximately 0. At this point, we can also go ahead and plug in because we have our observed and our expected. So we have an observed of 120 and expected of 100. And we're always looking at the first one and the last one. So we'll look at this one right here, and then we'll look at this one right here. And so then it's going to be 70 minus 100, which is our observed minus our expected over our expected. And there's our p-value. That's incorrect. That value is incorrect. That value should be 34. All right. That value should have been 34 like it shows on the calculator. All right. Now, degrees of freedom is categories -1. Well, we have 1, 2, 3, 4, 5. 5 minus 1 is 4. So our degrees of freedom are 4. All right. So the null and alternative, we have a couple keywords we have to pay attention to. Each type of pet has the same distribution of ownership among college students. Each and the same. All right. Then for the alternative, at least one does not have the same. All right. It does not have the same. So each is the same. At least one does not have the same distribution of pet ownership. Okay. Keywords there. Got to memorize those. So the next thing, our conditions. Well, first condition, random sample. Well, we had a random sample of 500 and that was given to us. The next condition, we need to make sure our sample is not too big. So we multiply it by 10 and compare it to the population. Well, they gave us a population size of 6,000. And so 500 times 10 is 5,000. That's less than 6,000. It ain't too big. We're good to go. So N is less than 10% of the population. The next one, we have to make sure our sample is big enough. To do that, our expected values all have to be at least 5. Well, in this case, our sample size, our expected values are 100. All expected values greater than 5, see table above. We could have said all expected values are 100, which is greater than 5. But see table above seems to be working pretty well for us. The next thing, our chi-squared value is 34. Well, that equals approximately 0. Really, the actual value we got was 7.4518 e to the negative 7, which means 1, 2, 3, 4, 5, 6, 7, which is 1, 2, 3, 4, 5, 6 zeros. As soon as we get to 4, we say it's 0. 0 is definitely less than our alpha 0.05, so our decision is to reject the null. And as I said over and over again, it is from this box that we start off our conclusion. Because our p-value is approximately 0, which is less than 0.05, we reject the null. Our p-value is approximately 0, which is less than our alpha 0.05, we reject the null. There is sufficient. Because you're rejecting, there is. We got lots of evidence to suggest that at least one type of pet does not have the same distribution of pet ownership among college students. And by the way, if you've seen any of my videos, you know that what I'm about to say. I'm about to say at least one type of pet does not have the same distribution of pet ownership among college students is exactly our alternative hypothesis. This is where our HA comes from. We always restate the HA at the end. So please make sure you write good alternative hypothesis. All right. Look forward to seeing you on the next one. I sure hope this helped.